name's Jackie Horsham and I'm here just to give you a little bit of advice about your HSC chemistry exam. I'm a head of science at Winona School, and I've also been an HSC marker for a number of years, a senior marker, and also been sitting on the HSC advice line. And actually the advice line is something that I would thoroughly recommend that you phone up before you come into, the day before your exam or a couple of days before. There's a number of teachers there that have really got expert advice, not only in the core of the HSC but also in your electives, because there's lots of different teachers that are teaching different electives. So you can get some expert advice at a time when you're not able to access your own teacher. So the HSC is made up of 20 multiple choice questions, and that was new last year. So lots of the past papers that you'll practice have only got 15 multiple choice. So just make sure that you're aware there's 20 multiple choice in the exam this year. And I recommend to my students not to do them all actually at the beginning, to start off, maybe do 5 or 10, the first 5 or 10 multiple choice, and then go on and do some of your longer answer questions. You've had your 5 minutes reading time before you do your exam, so go through that and use that wisely to have a look at the extended response questions and also your elective, because maybe you can just settle yourself into the exam doing 5 multiple choice and then go on and do some of the questions that you can do really well, because the multiple choice are only worth 1 mark, and particularly some of the last multiple choice questions you have to do a lot of work to get that 1 mark, and your time would be better spent working on a 5, 6 or 7 mark part in your elective or the extended response. So if we're having a look at, just building up some of our revision towards the exam, you've obviously made your notes on your dot points. Your teacher has gone through all of those concepts with you, but you need to make sure that you make your own notes on those dot points, and that you're also revising all of your practicals that you've done for your chemistry paper, because there will be questions in your exam on some of the practicals. It might be about how you did it, or it might be just explaining some of the results. It might be talking about the validity or the reliability or the accuracy of your practical. So make sure that you're very clear on those terms as well, the difference between the reliability, the validity and the accuracy of your data. Practice as many past HSC papers as you can. You should make the habit of going into the Board of Studies website and going on to the past papers. But not only just doing the past papers and looking at the answers, I really recommend that you go in and you have a look at the notes from the Marking Centre. The notes from the Marking Centre give you some very good advice about what it was in that particular year that they were looking for. Whether that question particularly was a significant figure question, or whether they were looking for a number of equations in their answer, even though in the question that wasn't necessarily stated. So, you might have been required to have given 2 or 3 answers. The notes from the Marking Centre will always tell you things like better responses included, this in their answer, or the better responses clearly contrasted the results. So they're very good advice. So do your question, look at the answers, but then also make sure that you look at the notes from the Marking Centre. There will be some questions in your exam paper that will specifically ask you to give equations. And I always advise my students to, and I advise you, to put in the states for your equations if you know the states. Don't put them in if you don't know, because if you're wrong, you might end up losing some of the marks for that particular question. But make sure that you've got your states there, and make sure your equation is balanced, not only for the atoms, but also for charge, particularly when you're writing half equations. Be very careful that charge is always balanced, because what you've got on the reactant side must also balance the charge that's on your product side. When you are writing the states for your equations, make sure that they're clear, because sometimes when we're marking, if a student writes, for example, solid, and they write it very quickly, that S can sometimes look like a G, and so therefore then we're thinking, is it solid or is it gas that they've written? So be clear with your numbers and your states. Okay, for calculations, it does say at the beginning of section B to show all of your working for calculations. So you do need to make sure that you show your working and show it clearly, because the examiners need to actually be able to follow what you're doing. It's a good habit to write down the equation that you're using first and then substitute your numbers. When you get to the end of your calculation, of course, don't forget that there will be some units, whether it's moles or moles per litre or grams or milliliters, whatever it is that you're calculating. Make sure that you put your units in at the end, because perhaps marks aren't going to be awarded unless we know what units you're expressing that in. Now, somewhere on the paper there's always a question that we mark the significant figures. So you need to make sure, really throughout all calculations in the paper, because you don't know which one it's going to be, that you're always giving your answers to the correct number of significant figures. Very often the question will have, for example, 25.0 mils of an acid was titrated. The concentration of the acid was, let's say, 0.156, and everything there, all that data has been given to you in 3 significant figures. So that means that really your answer should be also to 3 significant figures. So look after your significant figures in all questions, and don't round off your answer until your very final calculation. Keep your numbers in your calculator. Use your memory on your calculator to make sure that you've not inadvertently rounded down somewhere before the final answer. And then just check that your answer sort of makes sense, like logically that it's making sense, that you're not getting, some huge volume of a gas produced if you've only used such a tiny mass of substance. So think about what it is that you're calculating as well. You might get asked in the paper somewhere to draw a specific diagram, or perhaps when you're answering a question, a diagram might help. Remember, diagrams can often save you 1,000 words, particularly if you're trying to outline a procedure for a particular experiment. If you're asked specifically for a diagram or a labelled diagram, make sure that your labels actually touch the piece of equipment that you're labelling, as opposed to just pointing to some, point in mid-air. For example, also with, in the past they've asked questions like, draw the setup for reflux. So you've drawn your condenser and your round bottom flask, don't forget your heat source, but then it's not going to miraculously stand up by itself. You'll need some sort of support, so make sure that you also include in your diagram, your clamp stand, that type of thing, and label everything, right? Label as much as you can. And make sure that your diagram is sort of kind of roughly to scale, but make sure also that it's 2-dimensional. For instance, when you draw the condenser, you've got to remember to leave the top of the condenser open. So make sure that you haven't, put a bung in or something like that, or simply just closed off the top in your diagram. They don't need to necessarily be, the neatest of things in terms of using a ruler. I mean, it's a good idea to use a ruler, but if you're rushed for time, then, just try and get the general setup of that equipment down on paper. If you haven't been asked to draw a diagram, then, like I said, it's quite a good idea to quickly sort of slip one in, because it can actually say quite a lot of things for you. One of the commonest errors, I suppose, in the chemistry paper is writing equations and formula and writing the correct formula. For instance, students notoriously seem to get confused with ammonia and the ammonium ion. So if you're writing ammonia, you're writing NH3, and if it's the ammonium ion that you're talking about, it's NH4+. So make sure that you're familiar with the polyatomic ions and that you can write chemical formula correctly. Practice that. Practice all of your common polyatomic ions. For example, your phosphate ion, your carbonate ion, your ammonium ion, your sulfate ion. Think about your ions that you're using for your buffers, and think about your ions that you're using when you're looking at amphiprotic species. So make sure that you know those ions and you can write their formulas correctly. Some equations sometimes are better off written as a structural equation. For example, if you're writing an equation for esterification, it means more if you write it as a structural equation. So write out your alcohol and your acid, and then across your arrow, don't forget to think about the catalyst in your equation. So you're going to include, for that particular reaction, your concentrated H2SO4 as your catalyst, and draw out your structural arrangement of your products. Be careful with those equations as well, particularly if you're asked for structural formula or structural equations, to include all of the hydrogens on the bonds. You know, often in class you're just writing the carbon backbone with the dashes because you're being quick to write down the structural formula. But make sure that you're including all of the bonds in your actual structural formula. So don't be lazy, otherwise you'll be throwing away marks. If you're outlining a procedure, for instance, you're trying to outline an experiment to determine the difference between an alkane and an alkene, those sort of types of practicals that you've done, you need to remember to include approximate amounts of the reagent. So don't just say that you're going to add bromine water to the two substances. Say to the examiners, you're going to put 5 ml in a test tube of each, and that you're going to add 3 drops of bromine water to each test tube. So be a bit specific, because that's going to give you a much better answer than the student that just names the reagent. So think about your quantities. Think about what you're doing. Think about safety, because there'll often be a mark somewhere in the paper for some sort of safety aspect. So think about either protective wear that you need to have yourself, in terms of, gloves or goggles, or doing it in the fume cupboard, those sorts of things. And think about the disposal of the wastes as well. So often the marks are going to indicate to you how much depth you need to put into your answer. If it's 5 marks, then you've got to really be thinking, this is quite a thorough answer that I'm giving, rather than just if it was 2 marks for outlining the procedure. So think about controls for your experiment and how you performed it. Now, if it's asking you to determine the difference between them, you're going to have to give some indication in your answer of the actual result of that experiment, because otherwise, just saying what you're going to do isn't going to tell you how you're determining the difference. So think about indicating to the examiners what's going to happen, how you're going to know what it is that they're asking you in the question itself. For your extended response questions, things that are about 7 or 8 marks, you really need to think about your plan for that answer, because the Border Studies papers will generally give you 2 lines for 1 mark. So you're having to put quite a lot of information down to score the full marks. So think about drawing around at the top of the paper some sort of plan for your experiment, or some sort of plan for your answer, where you're going to go with your answer. Make sure that you're addressing all parts of the question, because often there will be in the question not only to assess something, but then it might also ask you to include equations or include examples. And if it's given the word examples or equations, there's an S, you're obviously going to need to give more than 1, because they were looking for a plural. So at least give 2 to 3 examples to, exemplify your point. Don't just sort of do a big brain dump where you're thinking, I'm going to write down everything I know about this particular topic, because the marks are for answering the question. So you need to make sure that you do address the question that you've been given, and that you're addressing all parts of that question. Think about structuring your answer. Perhaps even a table might help, or bullet points will help. You don't have to, in your chemistry exam, answer as an essay style. You can give dot points. You can use, shorthand, like little arrows, meaning going upwards for increase or going downwards for a decrease of concentration. So think about your answer, think about your plan, think about whether a table or bullet points is going to really help give that deeper understanding to your question. It'll also help avoid contradictions, I think. So somewhere in your paper too, there'll probably be either a graph that you've got to draw or perhaps a graph that you've got to interpret. So think about practicing all of the past HSC papers for graphs. Be very careful with manipulating the scale for your graph, making sure that you're actually reading that scale properly and you're actually plotting your points accurately, because we are expecting you to be able to plot a graph. So, you know, make sure that if the point is meant to be on the line, that it's actually on that line. Much better to use a cross than a dot, because often you can't see when we're marking a very fine dot. So think about plotting your points accurately, and then your line of best fit, which doesn't have to be a straight line. You can have curved lines of best fit. So make sure that you're practicing drawing curves, you know, that you're able to interpret the data that you've got. If you're drawing lines of best fit, often I advise my students to have a see-through ruler so that they can see the points that are above and below the line. It's much better to get a good line of fit if you're doing that. And think also about plotting the 0, 0 point, because if that's been given to you as some of your data, don't ignore it. You do need to make sure that you put that point on the graph. So make sure that that's logical. One of the best ways too to revise is not only to, you know, be reading through your notes, reading through your textbook, doing questions of course, but even think about writing your own questions. Think about taking, you know, a dot point from the Board of Studies syllabus and trying to write a question for it. Write yourself a 1-mark question or a multiple choice or a 3-mark or a 5-mark question. Use some of those different verbs like explain or justify. You know, those are different sorts of skills. So write yourself questions and then answer them. Or give them to your friend to answer, you know, swap questions over. Revise with your friends. Sometimes group work is a very collaborative way, you know, to revise, because one, it helps you ensure your understanding if you're trying to explain it to one of your friends. So think about working together in small groups, but you do have to be productive, you know, when you're doing it. You are working together and helping each other and clarifying ideas. And if you're still not sure on some of those ideas, well, don't forget, you know, your teacher is still there. In this electronic age, you might even be able to send them an email to get them to, you know, answer a question. Or like I said at the beginning, you know, it's the night before the paper, we'll phone up the advice line. Get that point clarified so that you are very clear on, you know, what you need to know before you're walking into that exam. Use the Board of Studies. They've got their online multiple choice where you can select, I'm going to do 15 multiple choice or 20 multiple choice, and they're just randomly picking them from past papers, and then they mark them for you, so that's even better, and they can tell you which ones you got wrong and right there on the spot, and the ones that you've got wrong, they'll tell you what the right answer is. So go back to it, use that to, you know, to learn. And if you did every multiple choice question that there's ever been on the Board of Studies papers, you've covered all of the core content. It's just the difference sometimes in the depth that you've got to give when you're giving a longer answer. So really use that, and it's a quick way to revise and make sure that you're understanding everything. Okay, so I think just some of my my final bits of advice to you. Well, one, you know, don't panic. Don't panic when you get into that exam. Try and keep calm. Take a few deep breaths. Like I said, start off with a few multiple choice to get yourself settled. Get a good night's sleep, because, you know, on the exam you don't want to be throwing away marks by making silly mistakes. By all rights, you should probably have 10 to 15 minutes to check through your paper. So don't sit there and think I've finished. Go back and check. Go back and check that you've included states, that you've, you know, drawn arrows correctly. Don't put equal signs in your equations, that sort of thing. Add states, check your significant figures, check your units, all those sorts of things. You might be able to pick up an extra mark because you've inadvertently forgotten to do that while you were doing your question. So use that time wisely, and good luck, what can I say? I hope you all do well.